Hi everyone, I am T. Ramesh, Assistant Professor in Mathematics, Dr. S.N.S. Rajarajam College of Arts and Science. In this lecture video, we are going to discuss about the initial basic feasible solution of transportation problem using Vogels Approximation method. So what are the steps involved in the Vogels Approximation method? Step 1. For each row of the transportation table, identify the smallest and the next to smallest cost. Determine the difference between them for each row. These are called penalties. Similarly, compute these penalties for each column. Next step, identify the row or column with the largest penalty and allocate as much as possible within the restrictions of the rim conditions to the lowest cost cell in the row or column selected. In next step, cross out of the row or column completely satisfied by the allocations. In next step, repeat step 1 to 3 until all assignments have been made. Now we have one problem for this. Find the initial basic feasible solution of the following transportation model by Vogels Approximation method. So here the supplies and demands also given and unit cost is also there. The total supply is 7 plus 12 plus 11, that is 30, and the demand total demand is also 30. Therefore the given transportation problem is balanced. So if it is so, there exists here feasible solution. Now we have the penalty. In first row, we choose the smallest cell. So in first row 1 to 6, the smallest number is. So how to choose the penalty? Choose the smallest and next is very smallest one. So in first row, the smallest cost is 1 and the next smallest cost is also 2. So difference of 2 and 1 is 1. So we put it that in the penalty. In second row, the smallest cost is 0, next cost is 2, the difference of 0 and 2 is also 2, so put it there. In third row, smallest cost is 1 and the next is 3, the difference is 2, that is we fix the penalty 2. Likewise, in the column side, the smallest cost is 1, the next one is 3, the next one is 3, so difference is 2. So not in the penalties, not it is exactly in the first column, the smallest cost is 0, next one is 1, the difference is 1, so put it in the column penalty. And in next column side, smallest cost is 1, next cost is 2, difference is 1. Third column penalty, in a smallest cost is 2 and the next is 5, difference of 5 and 2 is 3. Now in this row penalty and column penalty, we choose the largest penalty. So in the row side, penalty is 2, column wise largest penalty is 3. Among 2 and 3, 3 is maximum. Therefore we choose the third one from the column side penalty, 3. So it is 3 is the entire. So from that we apply the least cost method. So in this third column, which cost is minimum? 2. That is, it is in cell 2, 3. Second or third column 2, 3. So and we fix that its corresponding supply is 12, demand is 10. So from that 12 we transfer 10 supplies and fill the demand. So with unit cost of 2, so 2 into 10, there are 20 rupees we spend that and we fill the demand. After that we get 2 supplies available. So from the third, after filling that, the third column is not a demand, therefore block the third columns. Next we have second penalty 1 to 6, 7. So we choose a difference of smallest 2 numbers, 2 and 1. The second penalty is 1. In second row, we choose 2 different numbers, 0 and 0, 2 is also 2. And the next penalty side, 0, 4, it is a 4, and the next one is 3, 1, 5. The difference is 3 and 1 is 2. In the column penalty, 1, 0 is 1, the difference of 1 and 2 is 1, the difference of 5 and 2 is 3. So here the maximum in this both side, the maximum penalty in the row and the column penalty is 4. In second row it's a corresponding we choose a second row. From that we choose a least cost is 0. Its corresponding supply is 2, demand is 10. So I take 2 supplies and fill that demand. After filling that, we get 8. Demand is there, still there is no supplies available from the second row. Therefore block the remaining cells in the second row. Then third penalty. So third penalty, in first row we choose the difference up to cost is 1. In second row, the difference up to cost, already the second row is completely eliminated, so it is a dash. And the third one is 1, 3, 2. Similarly, third column penalty penalty is 1. Already the 0 is blocked, so 1, 3, 2. In second column 1, 2 is 1. In third column already blocked. So among this third penalty from row and column side, the maximum penalty is 2, but there are 2 2s. The first 2 in third column and second 2 is third row, so we choose the first preference of 2. So we choose the first column and the smallest cost. So smallest cost is again is 1 because already is blocked. First row, first column. From that corresponding supply and demand 7, and we fill everything. So likewise we have completed all these things. Then we get the number of basic cells, allocate all the cells. After allocating finished, then we choose what is the number of basic cells. How many basic cells? There are 5 basic cells, and the formula m plus and minus 1 is m is number of rows and number of columns. Here we have 3 rows and 3 columns, so 3 plus 3 minus 1 is 5. So number of basic cells 5, number of allocation m plus and minus 1 is also 5, therefore non-degenerate solutions. What is basic feasible solutions of this? How many basic cells where it is allocated in first row, first column, that is x11. There are 7 data are transferred, so x11 is 7, x21 is 2, x23 is 2, 10, x31 is 1, x32 is 10. It is basic feasible solutions. And the initial transportation cost is 1 into 7 plus 0 into 2 plus 2 into 10 plus 3 into 1 plus 1 into 10, that is equal to 40. Thank you.